So let's look at angle bisectors today. And so that big question is, what is an angle bisector? And an angle bisector is going to be a ray, a line, or a line segment that divides an angle into two congruent angles. A reminder, if we're talking about a ray, we got to put the right hat on it, which is just going to have a single arrow over the top, starting from the terminal side and going to another point on the ray. If we're talking about a line as an angle bisector, it needs to have the right hat of two arrows on either side. And if we're talking about a line segment is just going to have a line over the top with no arrows. A line segment terminates at both ends and does not go on forever. So just a reminder about those hats, but an angle bisector divides an angle into two congruent angles. So looking over at this example, we're given that angle BD is an angle bisector. I'm going to go back for a second. I'm going to talk about ray BD because I see the hat. Ray BD is an angle bisector of angle ABC. So notice ray BD, B is the terminal point, D is a point on the ray, goes out forever in one direction. It's an angle bisector of angle ABC. Knowing that, it divides ABC into two congruent angles, namely ABD and CBD. My geometric equation is going to be just that angle ABD is congruent to angle CBD. Angle CBD. A reminder, we could just for angle CBD, we could also call it angle DBC. And angle ABD, we can also call angle DBA. Those are similar names for the same, they're two different names for the same angle. So we have our geometric equation. We know that these two smaller angles are going to be congruent because that's what an angle bisector does. So let's look at two examples. Each figure shows a triangle with one of its angle bisectors. First, we're going to state the angle bisector of the given angle in the triangle. Second, we're going to write the geometric equation. Notice I'm going to write the geometric equation in red, and I'm going to state the angle bisector in black. And third, I'm going to substitute the given information and solve for the variable and find the information requested. Ignore the two spelling errors in those last two sentences. So looking at this first example, notice it tells me the measure of angle 2 right here, and I want to get away from talking about angle 2. What I would rather say instead of angle 2, and we're going to do this in our geometric equation, is I want to talk about angle FEP. Angle FEP. And similarly, instead of talking about angle 1, right here, I want to talk about angle GEP. So I want to talk about angle GEP. I'm not expecting you to change this on your work, but know that in your geometric equation, I don't want to see angle 1 plus angle 2 equals something. Okay. So notice we're asked to find the measure of angle 1, which is the measure of GEP. Looking at this, I see that my angle bisector is going to be line segment EP. My angle bisector is going to be line segment EP. Notice I have a single line with no arrows over the top. My geometric equation is going to be that angle GEP is congruent to angle PEF. Angle PEF. So substituting in my values, I know that angle GEP is the expression 3x plus 14. 3x plus 14. And substituting in the expression for angle PEF, notice I read that backwards, but E, which is the vertex of that angle, is in the middle. So angle FEP and angle PEF are just two names for the same angle. So I know that PEF is equal to 4x plus 6. So to solve this equation, I'm going to move the smallest variable to the other side first. I'm going to subtract 3x. I'm going to subtract 3x. And I get 14 is equal to x plus 6. I'm going to subtract 6 on both sides. And I get x equals 8. So notice it says solve for the variable. I got x equals 8. Good so far. But now I want to find the information requested. And I'm asked to find the measure of angle 1, which is GEP. So I know that the measure of angle 1 is 3x plus 14. Substitute 8 in for x, and I get 3 times 8 equal 3 times 8 plus 14. I know that that's 24 plus 14. I know that that's 38 degrees. We're finding the measure of an angle. Degrees measures those angles. While x can be 8, I hope to see 38 degrees for the measure of that angle. So those are the two things that I'm looking for in this problem. Let's go and look at another one, and you've got your practice looks very similar to this. So notice the measure of angle 2, and instead of angle 2, I'm just going to make this change. Angle 2 is WVP. So it's angle WVP. And the measure of angle XVW, that's the whole thing, huh? Okay. XVW is going to be 5x plus 12. We're asked to find the measure of angle 2. So my geometric equation, I know that angle XVP is going to be equal to angle WVP. But taking a step back, I also know that angle XVP plus angle PVW is going to be equal to angle XVW. So I'm actually going to write that because I think that's going to help me out a little bit more. I'm given this, the big angle, so angle XVP plus angle WVP. And notice I'm kind of going back and forth on how I name these interchangeably because while they're different names, it's the same angle. Is going to be equal to angle XVW. Angle XVW. Substituting in my values, I know that angle WVP is 2x plus 10. I know that angle XVW is 5x plus 12. Excuse me. And I also know that angle XVP has the same measure as angle WVP. So I could write WVP in place of angle XVP. So 2x plus 10 plus 2x plus 10 is going to be equal to 5x plus 12. Combining like terms, I see that 2x plus 2x is 4x. I see 10 plus 10 is 20. All of that's going to be equal to 5x plus 12. I'm going to move the smallest coefficient of x to the other side. That's 4. I'm going to subtract 4x. I'm going to subtract 4x. I get 20 is equal to x plus 12. Going to subtract 12 on both sides. And I get x is equal to 8. Again, I have solved for the variable, but I haven't found the information requested. I'm looking to find the measure of angle 2, which is PVW. But I know that PVW is the same as PVX. So I know that I can substitute 8 into 2x plus 10. So I'm going to substitute 8 in there, and I get 2 times 8 plus 10. I get 16 plus 10. I get 26. I know this is an angle that I'm looking for. Oh, you're really going to do this right now. And so I know that this is 26 degrees. And I'm done.